My name is Manas Pathak, a student of IIPS DAVV, and I welcome you all to this video. In this video, we are going to understand an important concept of computer graphics, which is polygon filling algorithms. This video is my submission for third internal assignment of this subject. So in this video, we are going to understand two major polygon filling algorithms, which are boundary fill algorithm and flood fill algorithm. First, we are going to understand the theoretical aspects of these algorithms, and then we are going to implement them in a C++ program. First, the boundary fill algorithm. It starts from a point inside polygon and paint the interior outward the boundary and the fill algorithm proceeds outward pixel by pixel until the boundary color is encountered. So basically in this algorithm, we start from an arbitrary point inside the area we wish to fill, and then from that point we move outward and fill the area until we encounter the boundary. It is used in interactive painting packages. If you have used Microsoft Paint, then you must have used the function of bucket fill, which works on the same principle of this algorithm. It accepts coordinates x comma y, and starting from this pixel, it tests neighboring positions to determine whether they are of the boundary color. If not, they are painted with the fill color and their neighbors are tested. This process continues until all the pixels up to the boundary for the area are tested. We can also set inner and outer boundaries to specify the area. So basically, if this is my figure, this is my area which I wish to paint or fill the color with, then if I start from this arbitrary point, then the algorithm is first going to fill this point, and then it is going to test all the neighboring points. Then filling the neighboring pixels, it is going to move outward until it encounters the boundary, which is this blue colored pixels you can see. So by this way, the complete polygon is going to be filled with the desired color. So there are two methods of implementing the boundary fill algorithm. First, there is 4 connected and then there is 8 connected method. These are the two methods for proceeding to the neighboring pixels from current pixel. 4 connected. We test 4 neighboring pixels at right, left, above and below the current pixel. 8 connected. In addition to the 4 neighboring pixels tested in 4 connected, we also test the diagonally positioned pixels. This method is used for more complex figures. Several methods also fill across horizontal span. This method requires less stacking. So let's understand the 4 connected and 8 connected methods with a diagram example. So these are the diagrams for 4 connected and 8 connected methods. In 4 connected, the 4 neighboring pixels are tested, which are at the top, below, right and left. And in addition to the 4 pixels in 4 connected and 8 connected, the diagonally positioned pixels, which are these 4 pixels, are also tested. As for the horizontal spans, if I take this figure for example, then for horizontal spans, if I start from this point, then it is going to fill this horizontal line first, and then it is going to stack this line and this pixel and this pixel on its stack. Then then it proceeds by filling these horizontal lines at top first, and then filling the ones remaining at the bottom. So by this method generally requires less stacking, while the 4 connected and 8 connected methods requires more stacking, as they consist of more recursive calls. So now if you have clearly understood the boundary fill algorithm, then the flood fill algorithm would be very easy for you. This algorithm is popularly used for recoloring area not defined within a single boundary. We start from a specified interior point and reassign all the pixel values that are currently set to a given interior color with desired fill color. So basically this algorithm only checks that if that the pixel under consideration, if it is in the color we wish to replace or not. If it is in that color that we want to replace, then it is going to replace that old color with the new color. Now we are going to understand the implementation of these two algorithms in a C++ program. First, I have included all the libraries which I would require, which are iostream.h, conio.h, graphics.h, and mat.h. Now using Brensenham line drawing algorithm, we are going to construct the boundaries of the polygon. I have created this function such that it can draw all slopes of line. It takes the initial and final coordinates of x and y of the two pixels as parameters, and the color of the boundary, basically the color by which we are going to draw our line. Then it declares dx and dy, which are the differences between the final and initial value of coordinates x and y. The value of x and y is set to x1 and y1, and it also declares variables sx, sy, and p. Then this algorithm checks whether the final value of the two coordinates is greater than their initial values. If not, then the step value for them would be set to -1. And if the value of final coordinate is greater than the value of initial coordinate, the step value would be set to 1. Basically, if the value of initial coordinate is greater than its final coordinate, that means there is a decrement from initial point to the final point for that coordinate x or y. Then we are going to check whether the value of dy is greater than dx or not. If this is true, then the slope of my line is greater than 1. We would set the decision parameter p to initial value 2 into dx minus dy. Then we would enter a for loop, the condition for which would be determined by the value of dy. We would iterate in this loop until the value of I is less than dy. For each iteration, we are going to set the pixel for coordinates x comma y with the color of boundary. Then for each iteration, we are going to increment the value of y by sy, and then based on the value of our decision parameter p, we are going to decide whether we have to increment the value of x or not. If the value of p is less than 0, then we are not going to increment that value, and we would add 2 into dx to the existing value of p. And if the value of p is greater than 0, then we would increment the value of x by sx, and we would add 2 into dx minus dy to existing value of p. In case the slope of our line is less than 1, then we would interchange the roles of x and y to obtain the same effect, which is done in the else clause of this function. Now moving on to the boundary fill and flood fill functions. For boundary fill function, it accepts the coordinates of the current pixel under consideration xy, the fill color, and the boundary color. Then using getPixel function, we get the information of the current pixel under consideration. If the color of that pixel is not equal to the color of boundary and the fill color, then we are going to fill that pixel with the fill color. The next four statements are the recursive call to these four statements are recursive call to the boundary fill function for the neighboring pixels. The first one is for the one at the right, then left, then top and bottom. I've implemented this function using for connected method. Then moving on to the flood fill algorithm, it accepts the coordinates of the current pixel under consideration, which are x and y, the fill color and the old color. Then using the get pixel function, we check whether the color of the current pixel is same as the color of old color. If they are equal, then we replace the old color with the fill color using put pixel function. And then similar to the boundary fill algorithm, there are recursive calls in flood fill algorithm for four connected method to the four neighboring pixels. Now in my main function, I have initialized the graphics environment using the init graph, and then I have calls to three Brensenham line functions because the polygon I am creating here is a triangle. Then using boundary fill, I have filled that polygon with red color and the color of my boundary is white. Then to replace that red color with blue color, I have used the flood fill algorithm. So now let's run our program. I've exported my program to Turbo C++ to run and execute and show you the output. So now I'll run my program. So now as you can see, using Brensenham line drawing algorithm and boundary fill algorithm, I've constructed this triangle with a white boundary and filled its color with area with red color using boundary fill algorithm. Here I have constructed a smaller triangle because the Turbo C++ version in my computer is 16-bit. Hence, to avoid the stack overflow, I've constructed a smaller triangle. But if you don't have such constraints, you can also construct a larger triangle. Now, if I want to change the color of this area with blue color, if I wish to replace the red color with the blue color, I'm going to do this by using a flood fill algorithm. So now by pressing enter key, I've changed the color of the area to blue, and I've implemented this using the flood fill algorithm. Hence, we have successfully implemented both the boundary fill algorithm and flood fill algorithm in our C++ program. So that is all for today's video. I would like to express my sincere gratitude to Dr. Basan, who guided me throughout the semester for this subject. If you gained some informational insights from this video, consider liking this video and subscribing to my channel. I would be coming up with more such exciting topics. Thank you.